Hi, Chloe. This is a great question. We are going to use the Lagrange error-bound formula. This formula is the absolute value of f of z minus t sub n of z is less than or equal to the maximum of the n plus 1 derivative of z times z minus c to the n plus 1 over n plus 1 factorial. A couple things to notate. Z is the value that we're trying to find the error for specifically. So in this case, z equals 1.2. N is the degree of the Taylor polynomial. In this case, the Taylor polynomial has degree 3. And then c is our center. In this case, c is 0. If it doesn't tell us the center, we can assume the center is 0. So once you plug all of this in, the only tricky piece is this max fn plus 1 piece. That's, again, the maximum of the n plus 1 derivative of z. In this case, we're trying to find the maximum of the fourth derivative of f. In this case, your f equals e to the x. Luckily, this is a really nice function. That derivative keeps repeating, so we know that the fourth derivative equals e to the x as well. So, oops, I put a star instead of x, so e to the x. So what we want to do is find the maximum of e to the x at x equals 1.2. That's just going to be plugging in 1.2. So the max of that function is e to the 1.2. From there, it's just multiplying by z minus c, which is 1.2 minus 0 to the power 4. We want to take the absolute value of that. So if you had a negative 1.2, you're going to make that positive. In this case, it's all positive. And then divided by n plus 1 factorial. So this is going to be your solution when you plug in your value for z, plug in your value for n. If you have any questions, feel free to leave a comment.